Joule's law of heating. Now, suppose you are taking a conductor. Suppose this is a conductor, and across it we are applying a voltage source, that is V, and the resistance of the conductor, let it be R. That is, this is the resistance actually. If we will write inside it the resistance, it is resistance. We replace this conductor by its resistance R. Now, current I will be equal to, according to Ohm's law, V by R, or V is equal to I into R, according to Ohm's law. Now, if we try to pass Q number of charge, Q amount of charge through the resistor, suppose from this point to this point, we have to pass this Q charge in time t, then current I will be equal to Q by T. That means Q is equal to Q by T is equal to the current I, or this implies that Q is equal to I into T. And we know that the work done W let is the work done to pass Q amount of charge through a potential difference V. The Q is the work done to pass Q amount of charge through 1 volt through V volt potential difference in time t will be equal to Q into V. Now, this time is important. We know that in t time this Q will be equal to I into T, that is V into I into T. This is the work done to pass Q amount of charge in the resistor in time t, and this work done is nothing but the heat generated or dissipated in the resistor. And again, if you will apply Ohm's law here, V is equal to IR, then we can write this as I into R into I into T, that is equal to I square RT. This is the heat generated. Now we can state Joule's law. How we will tell the amount of heat generated? This is the Joule's law. The amount of heat generated in a device or in a resistor is directly proportional to square of the current passed through it and the resistance of the conductor, resistance of the resistor, and the time for which current flows. This is the Joule's law. Now we can write mathematically H is directly proportional to I square, is directly proportional to resistance R, is directly proportional to time T. Hence H is equal to I square RT. This is the Joule's law. Now this is the first bit. Next is a 5 ohm resistor is connected across a battery of 6 volts. 5 ohm, a 6 volt source is there and 5 ohm resistance is connected across it. Now and here time is given that 10 second for which the source is connected across the 5 ohm resistor. So now current I is equal to V by R, 6 by 5, that is equal to 1.2 ampere. So amount of heat generated or heat dissipated, amount of energy dissipated will be equal to I square R into T, that is equal to 1.2 square into 5 into 10, that is equal to 1.44 into 50, that is equal to 14.4 into 5, that is equal to 72 joule. This much of amount of heat will be dissipated in the resistor.